Okay, question 10 of the Thermochem tutorial. Okay, so in this case, we are supposed to use relevant bond energy to calculate the enthalpy change for this reaction. So quick recap, what are the methods in which we can calculate enthalpy change for reaction? So of course, we have our energy cycle. Okay, that's what we discussed in question 6. Okay, we also can make use of the formula of delta H formation of my products. Alright, summation of all the enthalpy change of formation of my products minus enthalpy change of formation of my reactants. This is the question that we discussed in question 7, if you could recall. Okay, and in this case, basically we're using bond energy, which we are using the BERP method, the bond energy of reactant minus bond energy of product. This one we discussed in question 8, question and 10. Alright, these two questions. So in this case, it's a very simple reaction. Hydrogen gas, Cl2 gas, form HCl gas. Alright, so just count the number of bonds broken. 1 HH bond, 1 Cl-Cl bond, forming 2 HCl bond. So simply, right, 1 HH bond broken, 1 Cl-Cl bond broken, 2 HCl bond formed. Submit the values from data booklet 436, 244, 431 for each of the bonds respectively. You get answer, negative 182 kJ per mole. Okay, so this one to me, very simple, straightforward, very similar to what we discussed in question 8. Okay, move on to part 2. Part 2, we are supposed to draw an energy level diagram below to show each of the bond breaking and bond making process. Label each level with the appropriate formulae. So we have the energy axis over here. I have hydrogen gas plus Cl2 gas. Okay, so the lines here are indicated for you. So notice that this gap here is smaller and this gap here is much bigger. So logically, we know that bond breaking is endothermic. So these two arrows going upwards should be the breaking of the hydrogen bond and the Cl-Cl bond. Alright, so hydrogen bond or Cl-Cl bond. So which is stronger? Hydrogen bond is stronger. So this bigger gap will therefore correspond to the breaking of the HH bond, whereas this smaller gap will correspond to the breaking of the Cl-Cl bond. Okay, so let's take a look. This will correspond to the breaking of the Cl-Cl bond, 244. Then you can see that your Cl2 has been broken down to form Cl gaseous atom. This is a larger gap. The larger gap is basically because of the more endothermic process of breaking the stronger HH bond, 436. So you can see that your hydrogen gas molecule has been broken down to form hydrogen atoms. Okay, bond energy. Okay, last but not least, we know that this reaction here is exothermic. So the end product here will be actually your HCl gas, delta H. So from this process to this process, all right, the two hydrogen atoms Cl, because I'm supposed to show bond breaking, so I've shown the bond breaking process. To show the bond making process, it's a downward arrow because bond forming or bond making, in this context, bond making, right? All right, it's exothermic, so downward arrow, right? So the question now is then what do we label this arrow with? All right. So in this case, instead of breaking the HCl bond, I'm forming the HCl bond. So all I need to do is to indicate that with a negative sign in front. A negative sign in front of the bond energy will indicate that I'm forming bonds instead of breaking bonds. So negative 2 times of bond energy of HCl, which is negative 2431, because negative 2 times 431, because you're forming 2 hydrogen chloride bonds, right? 2 HCl bonds formed. Okay, so with that, again, the comment on the relevant gaps and larger energy gap should be attributed to the larger enthalpy change, which involve the breaking of HH bond. So as I said over here, right, you need to give the higher gap, larger gap here, because lines are drawn for you. You're supposed to complete the arrows, right? You give this gap to the H bond breaking. Okay, with that, we are done with question 10.